The last video of this week concerns XML, which is once again another file format. So XML stands for Extensible Markup Language. I guess they really should be EML, but X is so much cooler. And it's another format similar to JSON that's meant to convey semi-structured data. It allows for nesting of data, which makes it a lot more flexible than CSV, but in many ways harder to write programs for that use it directly. So XML is actually an example that you probably see all the time. Is HTML is an example of XML that uses a subset of all of the possibility, all the flexibility that XML can use on its own. It's heavily used in web services as well as in communications between databases. Because you can convey a lot of information in XML, it's often used in these kind of, once again, communication between services. JSON is also used there. XML is a little bit older than JSON, but many times they're used very interchangeably. Another place that XML comes up a lot is it's often used in text document formatting. So whenever you save those Word files or OpenOffice or LibreOffice or iWork files, those primarily are actually XML files under the hood that convey things like here is text and this part is bold and so forth. The last place it often appears in is in configuration files. Often particular programs you want a configuration file that says here is where you need to save things, here is where you need to read things in. That's often written in XML so that it can be used across different platforms and still means the same thing. Okay, so let's talk about what makes up XML. So XML is composed of tags and elements. So tags come in three types. Start tags, which have the alligator, less than and greater than symbols, and then a name of the tag in there. So this tag is a section tag. There are also end tags, which start with the slash, or excuse me, they start with the less than symbol, and then they have a slash in section, and they have the greater than symbol. And you can also have empty element tags, which start, you can see it right there. Okay, so an element consists of a start tag, an optional content, which is stuff between the start tag and the end tag that's coming, and that can be just straight text, or it can be other elements, or an element can be just a empty element tag. Okay, so some example elements here are, this is a head element with a start and end tag. There's also an H element here that contains some content between the start and end tag, which includes text as well as other elements. And we also have a end element tag here as well. Okay, in addition to just the content that can be between tags, you can also add attributes to elements. Attributes are name value pairs within either the start tag or the empty element tag. You're not allowed to have attributes in the end tag. And there can only be one value in each pair, so you can never say here is a name and it maps to multiple values. So instead, when you want to have multiple values associated with a particular name, a particular key, often you use a space delimited string. So you say, if you want to say tags maps to house, dog, car, you'd say this one string that's house space, dog space, car, and you'd expect the program that's using this XML to be able to be smart about going, oh, this is the same one attribute is mapping to many different values. But I think that's a detail that we're not really going to be going into here. So some example attributes are, in this person element, we have name maps to Josh, and location maps to BPS and engineering in this work tag. Okay, so now let's talk about well-formed XML. So a legal XML file needs to contain Unicode characters with the special caveat that those less than symbols, as well as the ampersand, which is used in other contexts for escaping characters, we'll get to that in a little bit, they're only allowed to ever appear in their markup delineation rules. You're never allowed to have a greater than symbol anywhere other than the opening of one of those types of tags. So what do? Well, you have to escape them in a way that we'll talk about in a little bit. Additionally, you also are required to have correct nesting. So when you have a begin tag, a start tag, you need to have an end tag that appears sometime later. And if you have empty element tags, those can appear pretty much wherever you want. However, you're not allowed to have missing tags, like you're not allowed to have an end tag before a start tag, and you're not allowed to have elements that overlap. You're not allowed to have an element that starts within one element and ends within a different element. Another important thing is the element tags are case sensitive, and so the beginning and end tags must match exactly character for character. As well, tag names exclude a lot of the characters that mean special things in this language. So primarily, you tend to stay with just normal ASCII letters. You're not allowed to have spaces in tag names. You're not allowed to start with a hyphen or a comma or a dot or numeric digits. There's a lot of restrictions there. And then the important thing to also note is there's almost always a single root element, and all of the other elements are combined within this root element. Okay, just like JSON, where there's only one data type, in XML there's usually only one root element. Everything else is just nested somewhere within. So, multiple choice question time. If you were trying to represent an XML document in a particular program, which of these data structures would you use? Okay, so now let's go through these. Now, once again, you have this kind of nested document with elements within elements. Could you represent it with a graph? Yeah, you can have a graph where each element points at the elements that are within it. You could also represent it with a tree, because once again, you have this nesting of parent-child sorts of relationships. In fact, a tree is probably a better representation than a graph because it's a bit more restricted. You're not allowed to ever have elements that point to things other than their parents or children. So it's really a tree is a better structure. Can you represent this with a hash table? Not really, because a hash table doesn't really represent the kind of nesting that's able. Same with a list, unless you're really using like lists of lists, and then you're really representing it as a tree again. Okay, so that's really all you need to know about the XML specification. Now I'm going to talk about actually two different types of schema for HTML. The first one is called the document type definition. Now this is from way back when XML was kind of first formed. This was really before a lot of the idea of really powerful schema was developed, but it's still commonly used. And so I want to talk about that and just give you, once again, an overview of how this particular schema works. So once again, like all schema, a DTD defines what is valid XML for a particular purpose. It adds constraints on what XML this particular program will accept. So it defines things like what are the allowed tags and the grammar, what elements can be inside of what tags in what circumstances. Details can be found linked here. And so the important thing to know here is there's a number of special DTD components that you assemble together to get things to work. The first one is this pound PC data, which stands for parsed character data, which really means text that has the characters that need to be escaped. There's also C data, which stands for unparsed character data, which is text that doesn't have those particular characters escaped, which usually means that they contain other elements. And there's also an empty tag to basically say that there's no data allowed within this particular element. So let's go through an example. So over here we have some valid XML. It defines a particular bookstore, and there's the name of the store, and it also has all of the topics or genres within the store. And then we have the name of the genre and books that conform to that particular genre. So for instance, we have the topic XML and a particular book with a ISBN identification number and a particular title and an author. And then we have the appropriate closing tags here. Okay, so maybe this is representing a particular book and a particular genre that goes to a particular store and so forth. Now, how would we specify a schema that says exactly what tags are allowed where? Well, here is, once again, don't worry about the details. It's really more important to understand these things in principle. Here we have an example document type definition. So we say, hey, there needs to be a bookstore element. And what's allowed within a bookstore? Well, in these parentheses, it says what is allowed within a bookstore in actually a kind of interesting form of regular expression. So the first thing should be a name, and then there should be a topic, and that plus sign, once again, like in regular expression, means one or more. So there should be one or more topics within this bookstore element. We also have the topic element. What's allowed within a topic? Well, it needs to have a name, and then it needs to have 0 or more books, denoted by the decline operator there, the star. And now what's in a name? Well, a name has parsed character data. It has text within itself. All right, that's not too hard. What's in a book? Well, a book has a title and an author. So what's in a title? Well, within the title, it needs to just have text. What's inside the author? It needs to have text again. And then we can also say, by the way, for each book, there should be an ISBN attribute. That's for the atlas. There should be an ISBN attribute which contains character data. And we also mentioned that this is required, that you can't have a book that doesn't have this ISBN number. All right. Once again, the details here don't matter. The important thing is a document type definition can be used to specify which tags are allowed where and what can be within each of those elements. Okay, so we've talked about DTDs. That was kind of the older form of how XML used to be schemed. But now there are better versions, which I'll be showing you guys here as well. So XML schemas specifically are a lot more powerful way to describe what is allowed within a particular XML document. They're actually written in XML, and as such, you can actually have a DTD that applies to a schema or a schema that applies to a schema. You can nest it all the way down as far as you want because they need to be valid XML as well. And so they provide data types that are a lot more powerful than just, is this parsed character data or is this C data that contains other text inside? And we'll show you that in a little bit. Details can be found linked here. Okay, so instead of just PC data and C data, you can specify types like integer, byte, string, floating point number, and so forth. And you can combine those together to say what exactly is allowed where. So what I'm going to do is I'm going to use the same instance of data before that bookstore example and show you a schema that can be used to constrain what sort of ways could you use this XML data. So we have the same bookstore on the left, and on the right we have the schema, and I'm going to show you in bit by bit because it's actually quite a bit longer, but it's a lot more powerful as well. So at the beginning you specify what version of the schema this is using, and then there's a bit of an annotation to basically say, hey, this is a schema that's supposed to represent what is valid XML for a particular bookstore. And then we actually get into the schema itself. So we start with by saying, hey, we have to have an element called bookstore. And what is the type of bookstore? Well, it's not any easy like integer or byte string. It is of type bookstore type, which we'll define very quickly. Okay. So next thing we do is we say, okay, we have this complex type called bookstore type. What's allowed within a bookstore type? Well, it needs to have an element called name. And what is the type of the content within name? Well, it has to be a string. The XSD is basically XML schema. And then after the name, you need to have an element type called topic. Now, what is the type of topic? Well, it's too complex. We're just going to call it topic type for now, define it later. And we say that it has to occur at least once, which by definition means that it can also occur more than once as well. Okay? And so that is the definition for the bookstore type. Now, of course, we said we defined this topic type, and that's what we have to do now. So let's go and specify what is the complex type named topic type. Well, it needs to contain an element called name that contains a string within it, a lot like the bookstore type. And then there also are elements named book, which have type book type, and they need to occur 0 times, which means that you can have none of them, or you could have 1 or 2 or so forth. And so that is the definition of topic type. And now we need to also specify what is a book type. Well, a book type needs to have an element called title, and it needs to have an element called author, both of which contain strings. It also needs to have an attribute named ISBN, which is of type ISBN. And then we say, okay, well, ISBN has a particular type as well, which we specify later. It is a simple type because it's not allowed to have nodes, or not allowed to have elements within it. And it needs to be a string. But even more than just any string, it needs to follow a particular regular expression pattern, which is listed there. And then we have the closing tags for that as well. So what an XML schema does is it basically says, here are the elements you're allowed to use. Here is how many you have to have where. Here is what's allowed within each one. A lot like DTDs, but this is a lot more expressive and you can get a lot more control over them. I'm not even touching on part of the way that you can get to very complicated specifications of constraints. Okay, so I've talked to you about 2 different ways to specify schemas for XML, this type of schema as well as DTDs. So the next multiple choice question here is, well, when should you use the XML schema, what I just showed you, versus an XML DTD? Alright, so this is a kind of hard question. I don't expect you to know this off the top of your head, but I'm going to try to walk you through the correct solution here. So you should use a schema when you care a lot about very specific data typing. When you want, so for example, in the IBSN number there, or I guess, the IBSN type, we could specify a regular expression that it needed to match. We could be a lot more saying, you can't just have your IBSN be dog, it has to be numbers with hyphens here and so forth. So if you need to be very specific as to what's allowed, schema is better. Validation speed. So usually you're not really constrained by how quickly you can check whether or not a particular XML document is valid. Usually that's a very fast part of the process. The slower part of the process is actually reading in the data and transforming it and doing all of that. But actually DTDs are actually a bit faster than schemas. They're really written back in a time when the validation process had to be instantaneous. Now schemas and XML and DTDs work very quickly, both of them, but if you really need that validation as fast as humanly possible or fast as computerly possible, you'd probably use a DTD. If you had particular occurrence constraints, like it has to occur between 1 and 4 times, the only way to do that is with a schema. But if you have more flexible occurrence constraints, you tend to use a DTD if you can just use the, star plus, those sorts of things. But in reality, if you're really going to go through the trouble of coming up with a version of a schema for a particular XML document, it's almost always better to use just a straight XML schema than to use the older DTDs. If you're going to put in the effort to do a good schema instead of these kind of old style. So I would accept probably the best answer here is if you're really going through the trouble, you should really always be using the newer XML schema these days.